Hello. How you doing? Welcome. Give me a second here. Okay. Hello! So we're going to continue with some reverse engineering. We're going to deviate a little bit from what we were doing last time. A little bit. So yesterday, I started to do some hardware verification-y stuff again. I have it plugged in right here. So I got the, I don't have the USB plugged in, but dumper, Souseiki Fammy, ROM, or a cartridge, and the RAM adapter in the back. So we're probably going to try and verify some more stuff on that. But I was having some trouble. I was having some weird trouble that I want to see if I can maybe get to the bottom of today. That. So what I want to do is I want to try verifying it on hardware, right? On the Famicom itself, not through the cartridge dumper. Hang on, I had it up a second ago. It's one of this guy's ROMs. What did I do with it? What the fuck? No, not that. What is this? Not that either. Cool, I lost it. Nesmon. There it is. This. Okay. So. Okay. Basically, Wasmon, but for the NES. Allows you to, like, inspect, what's it? Routines. It should allow. I haven't actually read through this, but I should do that. Bridgewater, how you doing? But it should allow you to inspect different RAM address or memory addresses on the system, and it's a very small program, right? So, this guy, right here, Takuika Ninja. Has ported that to the NES. And I noticed that the assembled source, the assembled ROM, the actual code is teeny tiny and fits in main RAM. Now, this thing shuffles around cartridge memory all the time. So, and some of that's what I want to check as well, right? I want to verify some of that stuff that gets shuffled around. So I want to see if I can run this from main RAM instead of ROM space, right? So just before stream, it's kind of part of why I'm a little late today. I started to put together a bare bones ROM so I could figure out how I would assemble something like that. That's what this is, and I stopped before getting too far in this because it was already like 1 o'clock, and I needed to eat. So, but yeah, so we're gonna start here. Less sword, that's good. Second firewood in a hurry. A little cold up there. Yeah, I actually warmed up a bit past few days here. It was like, what, 20 degrees last week, I think? Something stupid. Yeah. So, how I have it set up so far, I'm not sure if I can do this with a single linker configuration. I probably can, but I'm going to start with 2 separate linker configurations first, and then we can maybe figure out how to get them in one. So the Souseiki Fammy code has given me this idea to basically have your startup code, do all your initialization crap, and then go right to a copy loop that copies all of the actual code you want to run, and then we'll just jump to that afterwards, all right? And that code's going to be, from over here. So I'm writing the copy loop, and then I'll figure out what I want to actually do here. It might just be a loop with a JSR to somewhere else that doesn't really do anything. Just as like a proof of concept, so I can see it running in Messen, and then I'll see how I can get the Nesmon stuff into that thing. Yeah. Got delivered 2 cords of firewood and had basically 10 hours to stack it and cover it before it started raining. Ooh. Oof. Yeah. Oh, how's that quack? All right. All right. So yes. So I need the size. So okay. So this is going to be however large this is. So I need the low byte of that. Store that into size. Whoop. Size plus 0. Get the high byte. Size plus 1. Okay. And then we're going to decrement that until it's 0 while we copy. Now, during which time I got called in to deal with a production incident at work, and we needed to get TARS to the hardware store before it closed. Oh no! All kinds of chaos. Lovely. All the chaos. All right. So we're gonna load up. Load Y 0. This is gonna be a slow loop, but that's fine. But they waited just for that. All right. Load source at Y. Store that into destination at Y. And this isn't going to be full pages, so we're not like copying a full 256 bytes at a time. We're just going to copy just as much as we need, basically, right? Yeah. Which means we're going to decrement size. And then branch not equal. No. Nope, we're not going to do it that way. We're going to set the carry. Load A. Size. Plus 0. Subtract carry 1. Store that size. Plus 0. Yoink. Paste. Plus 1, 1, and then 0. And then we're going to load up A. Size plus 1. Branch not equal to copy loop. Load A size. Thank you for the follow, by the way. Appreciate that. Size plus 0. Branch not equal. Copy loop. So, in theory, once both of these are 0, it will finish the loop. And then jump to code destination. That is going to be at 300. Okay. Then over here. Oh, I need NMI actually set to something. NMI needs to be set to not there. Actually, oops. NMI and IRQ. If I can get the right comment character, Jesus. Those are going to be somewhere in here. What is that? Import? NMI and IRQ. Is that how that works? So this guy's gonna export. Actually, let's do this. NMI. Res 1. IRQ. Res 1. No, we're going to res 3 for each of these so I can, what's it? Do a jump or something? So I can do a jump somewhere? That's, yes, okay. So that means I need to load up. Nope. 602. Jump. Opcode for that is 4C. 4C. Store that into NMI. Plus 0. Load 0. 1 and 2. And we're also going to do that for the IRQ. Okay. So that will this will reset it to nothing for now. Because we have it turned off. We're not doing any NMI or IRQ stuff right now. Yeah. And then the code desk is going to be the reset here eventually. Yeah, probably fine. Okay. So over here, we're gonna need to start with the reset code, whatever the hell that is. Do that. Let's get a the wait for NMI code that I've got. Where the hell is that? Utils? Yeah, okay. Yoink. Paste. Cut that. Rotate. Get rid of that. Sleeping. That segment. 0 page. Res 1. Actually, I do need that open again. Tetris, and then main NMI. My handler. No, I just want to increment sleeping, don't I? What if I reset that? What? No. There. Yoink. NMI. Paste that there. RTI. JSR. Wait for NMI. Okay. We do need to turn it on though. Reset code. No. Reset. V blank. Yeah. Oh, damn it. This is a bad example to look at. Where's Pooh? How you doing? Welcome. Main, no, main as this one. Reset, there it is. Does a bunch of stuff, and then pass. I don't really care for all that. Turns it on. That's what I wanted. Pop. So that turns on NMI. Oh, that does the same thing here. We're fine. Fuck it. My project, it's coming. It's doing. It's a doing. Okay, so not a lot of code. That's fine. The goal is just to get this compiled into the correct, or assembled rather, into the correct address space, and get it loaded and running from there. All right. So this is my configuration for that. Only defining 2 segments. I don't even have the vectors defined, which is fine. Just a bit of RAM code. That's fine. SP. The other one right here is where everything else is defined. This is where the code's going to be copied to. This is our ROM code. Hopefully this works. I don't actually need these, do I? I'll need something for that. What do I have over here? No, there's one where I want just, is it the key test one? Is that one? No, that'll work. Key test images. I'm using that for the key test. Right? Then key test. Tile map, not that one. Debug tile viewer. Yeah, that'll work. So we're just gonna copy that actually. The font. Copy that to here. Nope. Main. Okay, I need the 2 CHRs. Segment chur 0 and chur 1. Ink bin font.chur. Yoink paste. Okay. And down here I've also got an ink bin for the RAM code. Okay, so now make file. There it goes. I need ramcode.bin. That's going to be from ram.asm and ness underscore ram fug. Actually, I need that as .o, don't I? Ram.o. Stop that. Stop it! And then I need to figure out what the hell that is. Why that's breaking. Right, and the O. Sources, okay. Ram.o. Actually, it should be just anything.o. Should be that thing.asm. Right? So I can do that. The flags. Yoink both of those. Put them there. I need... Ooh, No, that config needs to be different depending on which ones. Okay. So we're gonna do ram.o needs ram.nes ASM and that should be it. CA65 GT NES. No, the .o is fine. The linker is what we need to yeah, LD flags. This one here. LD65. I need the flags. So C NES config is going to be NES underscore ram.cfg. I don't really care for the debug file. Or most of the other shit, I think. Yeah, I don't really care for the map file right now. Output is going to be $@. Input is going to be the first one. Okay. Okay, and then main dot ramtest.nes. Gonna need main.asm and also that. Not asm, that's gonna need o.o. And nes nrom.config. Yoink, paste. This one is gonna do the debug file. 3D Code Warrior, hey doing? Welcome. That one is gonna be yoink, paste, debug it. And yeah, we'll do the map file as well. Yoink, paste, map. Jamaica, how you doing? Welcome. Paste that there. Okay. Then all we want that guy. And then clean rm star.o and star.bin star.nes. Okay, we're not getting rid of the CHR because we're not rebuilding that every time. Let's see how badly it breaks. No such file or directory because you didn't fucking build it yet. Why didn't you build it yet? Huh? Make ramcode.bin. Okay, well. We don't need that. Load A, that. Make that. Unknown type? What do you mean unknown type? Nes underscore ram.config. Type RO, type ZP. RORW. That's not an unknown type. Load type, load type. Huh? Who knew figuring out assessing the society between different generic specializations was so difficult? Writing it down is hard? Yeah, writing down a lot of things is hard. Um, what in the fuck is the unknown type here? There isn't much to... Huh? I copied that. Fuck? RW, RO. RW, RO. No fill values. Their starts and sizes. Huh? Memory section, we also have a type. Valid types are RO and RW. The memory section. RW, RO. Is there like a verbose something or other so I can see exactly what the fuck the error is? Like where it is, rather? Verbose mode, yes, V. Make file. V. V. That's the wrong one. I need that. I need that. I need that. Okay, I'm passing in the wrong shit. That's why. That's why. I passed in too much shit. I was passing in the config as fucking an object file. Copy loop undefined. Huh? Oh, because... No, we're just doing like that. Make mcode size undefined, because that's... There's an underscore in there. Underscore, underscore. What the fuck you mean unknown option debug? Debug file. Missing INES hat. How the fuck? That should be this guy here. What do you mean? Do I have to explicitly define that? I don't think I do. HDR. Oh, okay. Oh no, I don't want to do this. That should be this. How? Huh? Why is that backwards? Why is this not? I mean... Yes, fuck it. Paste it there. INS HDR. So whatever. Make. Did I... Can find... What the fuck you mean? That's NROM. Oh, because... Cannot put RW second ROM code into read-only memory area PRG. Okay. ROM code. Ooh. That. Should be that. Our W there. Missing segment. What the fuck do you mean missing for vectors? Vectors 0. No. Vectors. Just vectors. There we go. Okay. 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 RAM code. My read-only ROM and my write-only RAM. A read-only RAM. Messin. All right, file open. Where is it? Could not load file. Try that again. Now. Could not load file. Fuck you. Okay? Why? Why? That was probably it, actually. What is hex 8 plus 4? That no, fuck you. 8 plus 4C. No. I need that of size 8. No, that was right, I think. Yeah, that was right. Okay, yeah. All right. But I didn't have that set up right. Okay, let's try that again. Open. No. There we go. Okay. Where are we? We are not running from the right place. Okay. What happened? What happened? What happened? Reload. Okay. All right. I have my my stuff in. Yeah. Okay. Okay. What the fuck happened? So we're doing a bunch of that. Sure. All right. Size. Okay. Start. No. source, and destination. Okay. And then we're also going to have a look at memory viewer. Reset all that. Yeah, that's fine. Okay. Okay. I don't actually change the pointers. Let's try that. Okay. Over here. To game, reload ROM. Back over here, back over to here. Okay. Now. There we go. It actually advances. Oh my god. Okay. Itty bitty. That's fine. 4 seat. Zeros. And then we're going to jump way up here. Ooh. I hate how it has a label every fucking... okay, edit that. Length 1. Shut up. What the how? Why did it JSR into that? Huh? Because I know why. Because I did it wrong is why. Because I put the NMI and IRQ up there, but I did not account for that. With this. We're going to put these in the stack. That's where we're putting those. Start 100. Size is going to be, if I get 100. Type RW. File is nowhere. And then going paste, stack, load, stack, type BSS. Missing memory. What do you mean? What the fuck there? What do you want? That's not the right config file. It's over here. God damn it. Put it there. Put it there or right there. Okay. There we go. Okay. Never too many labels. Yeah, right? Never too many. Corpse incomplete. Nice. That was boat number 4? I think it's 4. So yeah, so I finally found the queen the other night. But I only found the queen because I cheated a little bit. I found a map generator thing, and I had to look to just where all the boss whatever the fucks were. Turns out that queen, what's it? The queen marker on my map that I had that I couldn't find the entrance to. Yeah, that wasn't valid. So I've had that save across a few updates, and I think that's what happened. Is it got a little wonky with one of the updates, and oops. I lucked into it. Yeah. So I was searching for a while, and then I just gave up. Like, you know what? Searching through the Mistlands is a royal pain in the... Exploring the Mistlands is a royal pain in the ass. Royal pain. So I just wanted to know, like, what continent the fucking thing was on, right? What continent she was on. So I found a continent, and I beelined it towards that. So... okay. Memory viewer... reload that. So... that anyway there. Okay. And that's... 103 and 100. Yeah, okay. Good. Right. Yep. Now those would need to be set to something. I need to remove that. Edit that. 1 byte. There we go. Okay. JSR, load that. Turn on NMI. I need to set the NMI first. Because it's currently set to no. That's okay. 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 RAM ASM. I need to set it to this. And then the IRQ. I need to set to this. Let's put a new line. Okay, so load up. Low byte NMI. Going that, we're gonna put the stack in here again. RAM. Yoink. Paste. Yoink. Paste. Okay. Yeah, so now I can just use that. Ooh, NMI real and IRQ real. Well, the low byte to that, store that into NMI +1. Going paste. I need the high byte +2. Going paste. IRQ. IRQ. And that should work. Push I, pull I, make over here, reload, debugger, this guy, edit, 1 byte. Okay. Why didn't that work? Reload ROM. Okay, that looks a little better, I think. hopefully. I really need to modify this to not be 700 goddamn bytes long. There we go. Okay. Load it, store it. Load it, store it. Load it, store it. Load it, store it. Okay, so down there. Those look good. Bit source. Yeah, well. Okay, and where are we in the... Okay. We're going to... Right there, that's where it is. Beautiful. Identified... Show. So dumb, I love it. Okay. So now the question is, can I get this into a single config so I don't have to bother with what's it? Creating a bin file that I include later on. That's the next one. All right. We're gonna add some stuff though first. We're gonna create a Git though first, repo. Ignore star.o, star.bin, star.nes, star.debug, star.map. Ignore makefile main asm nes2 header inc start.config and ram.asm. Okay. All right. So now we want to see if we can get this into a single file. Okay. RAM ASM, RAM code. But that will need its own segment, obviously. RAM code, and ooh, RAM code, ooh. This one will have to be, like, in RAM, in ROM, maybe? And then we're gonna comment that out, and then do this. Yoink. Paste. Okay. Well. I don't know. That doesn't seem right, though. Maybe? Okay, so segments, RAM code, RAM, RAM code ROM, I don't need this one as its own separate segment, actually. I can just put that in the VSS. Right? As long as I'm not using anything else. Maybe? RAM code, yeah. RAM code in ROM. Load. PRG0. Type RO. Where is this guy here? Memory segments. What are the things I can use here? I need all the definitions for that. What the fuck? Overwrite, start. No. Alright, some part or parts of the segment of the one pass you're modifying OS around the specific routines that fix well-known addresses. You want to prevent them from shifting to other locations in memory, or if your change code takes less space. Or updating a block of code that available in binary. Minimize the service existing code. Overwrite segments we're considering. Okay. No. Assuming the original contains the original code, it's disassembled, provided in binary form. I using ink bin. Subsequent 4 segments will be relocated to addresses specified by their start offset attributes. Offset can also be used, and then we'll overwrite whatever was at these locations in the original segment. In the end, the resulting binary output file will thus contain the original data with the exception of 4 sequences starting at 9. No, I need that. One of 4 drinks, I'm completely missed. You ever see Airplane? That movie? One of the characters there has a drinking problem. It tells a story, right? That's how my drinking problem started. Takes a glass, right in the eye instead of the mouth. That's his problem. He has trouble drinking. Made me think of that. It ain't alcohol. He had like orange juice or some shit. So his drinking problem was that he just couldn't get the glass to his mouth. Okay, so this actually needs to be over there. That's going to be ROM. In ROM, this is going to be RAM code _ ROM. That is going to be in a file. File equals %O. Fill equals no. Because this is like the order it'll appear in the file. And he had an alcohol dependence by pointing to no, his problem was he had trouble drinking anything because he kept missing his mouth, which is oh my god. 15 years ago that was put up there. The movie's significantly older than that, but
It was at that moment that I first realized Elaine had doubts
oops.
about our relationship. And that
Hang on. Yeah.
it was at that moment that I first realized
You can't hear any of that. Turn that on. Try again.
it was at that moment that I first realized led to my drinking problem. We did come back to the States.
Dun dun. I don't think you could hear that very well, but you get the idea. Old movie, dumb as hell, but I love it. Okay. So let's see if this works. Sleeping undefined. Oh, okay. Sleeping. Res 1. Attribute expected. Got chur 0. LD 65. 10. Did I forget? I did. Expected vectors. Huh? Oh, I did it again. RO. Yeah, who cares? Make. Hang on. Why? Oh, yeah. Let's get rid of that. I want to make sure that it ain't in there. Okay. It isn't built. Since we're starting to see the first sign of the coming AI bubble pop. Thank God. Okay. Game reload ROM. All right. Let's go down to the copy loop right there. Oh, that. Thank you. Okay, and my stuff up there. RQ. Where the hell is? Oh, it's right there. Can't see it. Code destination. All right. All right. Load Y. Source. Dest. Why is source 300? Source should not be 300. Was it not included in the ROM? That was a mirror. Okay. In ROM. Okay, where the fuck did it put that? Invalid opcode? How? I literally just reset the fucking thing. Okay. Where the fuck is it putting this file? Is it not putting it anywhere? Like, what the fuck? ROM code in ROM. What am I doing wrong here? OpenAI CFO tried their best not to say it, while basically saying that they're hoping for the government to already prepare some bailouts for. Oh my god. I think they better not get any fucking bailouts, I swear to god. Okay, so this should be putting it into the file, right? Give me a fill val. Make. CV the less. I see why. It is outside of the size of that. Okay. Okay. You're gonna bail out. This needs to be smaller. Like that. Or no. No, that needs to be on top. Oh, God. I need that loading inside of PRG0, but at a different start address. How in the fuck is that supposed to work? So this will put it at that address inside that bank, but if I put it at, say, 300 there, that'll be outside the start of that, right? Like this, start at BFFA, puts that at that address in memory. Inside the segment. Right there. And I need that padded out so the ROM fucking loads. Unless, I mean, what I could do, I suppose, is I could just put it in the upper bank. Well, the upper half. I don't know. I don't think that would work, actually. I might need to just have the two files out and include the bin. That's probably the easiest way to do it, actually. The less headache way to do it. Yeah. All right, let's undo this stuff. Yeah. Okay. Reload. Let's stop there. Edit that. 1 byte. Oh, why do I have to read RWX? Get out of there. are there. Do all that stuff. Yeah. And the other one is the IRQ, right? Or nope, that's just that. Up to the top, over there. Okay. Good. Good. Now then. We're going to see if we can modify this to do the same thing, basically. Fun. Actually, let's get out of there. Detach. Well, it's fine. CD up. CD Nesmon Timox. I don't already have that open door, do I? No, that's the dumping, and then that's reversing. That's the emulator. That's the FDS stuff. Okay. Okay. So this one here, vim nesmon.s. This is the code for all this. All right. First things first, we're just going to get this running as is. Make sure I know how to use the damn thing. Okay. I can go over there. No, this one. Up, down, cycle of the characters. A, input. B, delete. Start, run input. Select, escape. Okay. All right, so how the hell does this actually work? Using it. The example one did not come with a reset circuit, which means the user... Okay, yeah. Once you do that, a backslash is printed on the screen, the cursor will drop one line. The cursor position is represented by a flashing @ symbol. You can type address, data, and commands, which will be executed as soon as you press the return key. The input buffer can hold up to 127 characters. Sure, that's probably incorrect for this, but that's fine. Address inputs are truncated. Sure. If an error has occurred during the processing input line, ignore that warning. Commands executed before an error are executed normally, though. Okay. Examining memory. You can examine the contents of a single memory location by typing a single address followed by return. Okay. So let's see how this works. Oh boy. So 0, 0. And what was return? Start. I forget what I have mapped to start. Start? Okay, that's start. 6D. 1 or 0. 0. Uh-oh. 0, 0, start. Okay, 0. 1, start. That was a select. 0. 1, start. Okay. Oh boy, this is gonna be painful to use. This is gonna be painful. Now let's examine a block of memory from the last open location to the specified location. Dot 5A. Note 4F is still considered the most recently opened location. You can also combine the previous two examples in one command. 4F.5A. Okay. Well, the first location of block 4F is considered opened. Okay. You can examine several locations at once. All addresses on one, with all addresses on one line. Okay. Exchange combines and block and single addresses. Line. Okay. Successive blocks of memory. And if you want to examine a larger block of memory which will not fit on one monitor screen, remember that there's no way to halt a large examine list other than hitting the reset button. Depositing memory, changing contents. That's how you change a single memory location, provided it is RAM memory, of course. FF is what location 30 used to contain before the operation. Now it contains 0A. Location 30 is not considered the most recently opened. Okay. Now we're going to deposit some more bytes in successive locations, starting from the last deposited location. Okay. 31 now contains A1, 32, A2, so on and so forth. Okay. Combining gives us this. Location 30 used to contain FF in this example, so that's what it shows first, I guess. Command means start depositing data from the most recently deposited location, or if none, then from the most recent. Okay. Running a program. R. Oh. Note the cursor is left immediately to the right of the displayed area. Not return to the next line. This program is responsible to control the rest of the output. Now on the right, the user. Okay. Okay. So, let's... Okay. 0, 0. Start. And then dot. 8, 0. I think that was I entered that incorrectly. That's just gonna keep on going, isn't it? I mean, okay. Pause that. And reviewer. I mean, yeah, okay. All right, yeah. Yeah. All right. Let's see. Now, should I be able to use my my EverDrive in this thing, you think? Or should I find that sacrificial cartridge? What do you guys think? I know I won't be able to like copy stuff from the EverDrive to a disk or whatever, but that's not what I'm looking for at this point. Find the cartridge? All right, give me a minute. See if I can find it. So I found the case, and then it occurred to me it's a NES cartridge, not a Famicom cartridge. So it wouldn't even fit in the fucking thing. Where are my adapters? Mess! Something with that. Something proper with this as well. Over here. Thought they were. My adapter tower with the IRQ scratched out. Okay. Don't actually know where this thing is. The cartridge. Because like I said, I found the case for it. Case is empty, so that does me a lot of good. And it's not with my other cartridges. For whatever reason. And it's not an easy one to miss because it's a clear one. Let me look again. I'm gonna hit the bathroom while I'm out too. Give me a few minutes. I had a revelation. I have a disk system. I could just put it on a virtual a disk system disk. So instead of running from an NROM, it's running from the RAM from a disk. Copy that to main RAM like I would have anyway. The NROM cartridge was only just to get it onto the RAM. Okay. Change of plans. Slight change of plans. Okay. I need to figure out how to build a Famicom disk system cartridge. Disk, whatever the fuck. I just noticed I screwed that up. Hang on. Are there any tools out there already to make FDS stuff? FDS. See also. Oh, fantastic. Sample. Minimal NES example using CA65. This is a very small example program for the NES, intended to demonstrate how to use that to build a NES ROM. It's very basic programming NES. This is a version that you want to build ideas. True FDS. Oh, that's this tree. Okay. Okay, we're gonna copy that. Let's go out of that. It's fine. CD up, git clone that, CD nest that, Tmux. What are differences here? Origin FDS. That's not what I wanted to do. Hit checkout. Origin FDS. Whatever, we're fine. Okay. Compile example config symbols. No. Yes, symbol S. Okay. Dot S. Consider simple and efficiently try to sure. All right. Header. Yep. File count 5 plus bypass. Set the file count one higher than the files on disk. License bypass technique. Okay, sure. Side A, all that crap. Fine. File 0, head. All right, all the header crap. Yep. File 0, file 1, 2, and 3. Sprite chur, background chur. Okay, those are in there. They are. Okay. Oops. Sure, whatever. That works fine for the example. All right. What did I change? All right, that's what I changed. Segment file 1 header, file 2 header. Okay, so yeah, those are all the segments. If bypass not as this block is used. This block is the last to load, enables NMI by loading the NMI enable value directly into the CPU controller register at 2000 while the disk loader continues searching for more boot file. Eventually the NMI fires, allowing us to take control of the CPU before the license screen is displayed. Sure. Alternative to the file license bypass, just required copyright message. Yeah. Vectors. Checkpoint, is that in there? Yeah, that is in there. Okay. NMI. Bypass stuff. Sure. Reset routine. File 0. Bypass. Okay. Machines entered by the last boot. Reset. In most cases, the standard reset stuff. F9 to FF is used by the BIOS, so we don't want to reset those. Okay. Yeah, so the FDS uses part of the stack in 0 page, so we don't want to clear the whole thing. 100 to 103 is used by the BIOS, so we don't want to clear those. Clear all sprites. Yeah. Whatever I use for wipe unused portion of FDS RAM between file 1. Sure. Wait for a second, leave blank, and then jump main. Okay. Browser dat. Why is it? Why are they split like this? NMI. Okay. Save to prevent NMI re-entry. We won't store that. Current frame counter. Sure. I'm doing my update loop. Scroll. View update end. RTI. Okay. Why are all the separate segments there? I don't like that. There's a truck sitting outside. It's noisy. Driving me up a wall. Skip users and like someone did not update. What the hell are these? I just want someone is also memory address to what? Huh? Update tile. Alright. Yeah, we're not going to be using the vast majority of this. But what in the fuck? Okay, whatever. We're gonna have a look at next the config. All right. Server page OAM BSS. Sure. Header. Okay. Side 1A. Start at 0. Size that. Okay. Oh, right, because that's the file stuff. Oh, ew. Okay. Page 0. Deck 1. 0 page align. Okay. Header. Side 1A. Side 1A. RO. Load. Oh! Okay, see? This is what I needed right here. That's what I needed. That's what I fucking needed! Run equals PRG 0. We're gonna put it in this segment, but we're gonna run it from here. That's what I needed for the other one. God damn it. Where the hell is that in here? Load and run it. Right the fuck there. All right. No problem. If the code runs in RAM, we do not care about the read-write data. But now the code is in ROM. We must care about it. Remember the default segments. You can probably get short. BSS is not initialized. We must, what about data? It contains initialized data. That is, data is explicitly assigned a value. Right. First, we'll rely on these values on startup, since there's no way to remember the contents of the segment. I think it won't copy the ROM into RAM for you. Yeah. but it has some features to help you in this process. First, you may not only specify a load attribute for a second, but also a run attribute. The load attribute is mandatory, and if you don't specify a run attribute, the linker assumes that the load area and run area are the same. Yeah, okay. So, neat. Oh, no. RAM code. Well, no, I'd need, I'd still need to find out where that's from, so I can load it. So, that's fine. Because this loads it. The BIOS loads that, not our own code. Yeah. They load this at the address with the segment is loaded. Okay, so I need to. I would need to use that. That's okay. That's fine. That's fine. Yeah. Oh, God. I'd hate that. Yes. Example .o. Anything .o is going to be .s. 665. G-O that, and then the first thing there. The first thing there. LD65. Output is that. Don't really care about the other stuff. And that's going to be add breakpoint execute anything from 5,000 to DFFF. Okay. Oh, big control. Oh, is this the bypass crap? That's some bypass crap, isn't it? Again, execute anywhere from 5,000 to DFFF. Okay. Okay, we're in the init code. All right. Sure. Memory viewer. I'm 6,000. All right, that's tiny too. How big is that? 6,002. 6,420. That's not bad. Well, at the very end here is going to be the BIOS. There's the BIOS. Okay, so first order of business is just getting that to run. Getting the monitor to run just as from a disk instead of from a ROM. That's step one. Then step two will be copying that to RAM and then running it from there. Yeah. Okay. No. QI. QI. Okay. That's mod. Tmux. LS. Vim. That's mon.kfugu. Nest.kfugu. Oh, E, thank you. There. Okay. Oh, did it? Vectors, yeah, sure. Header. That's fine. Yoink. Paste. Val equals 0 that. Okay. This is in there. Code. No, we want header side A. Vectors BSS. No, BSS. We're gonna put that up there. Okay, and then I'm just gonna copy this stuff. 0, 1, 2, 3, 4. Yoink. Paste. These guys are going away for now. Vectors. That is also going away, actually. Okay. This one, this. What? Nope. And this one, that S. God damn it. Q. There it goes. Over here. Over here. Okay. Segment header. That's going to be all different. Ugh. All different. Yoink. Paste. One side. Okay. Vectors. Hey, we're not doing that anymore. We want a side A. Yoink. Paste. Header 0. File 0 header. File 1 header. File 2 header. File 3 and 4 header. Oh, that's the bypass stuff. Yeah. Yoink. Paste. Right. That's all the bypass crap. I'm leaving that as is. Yoink. Okay. I want that bypass stuff. Okay, sure. There's more reset stuff. Okay. All right. Zero page uses word. I might want to. Where the hell's that shit? Actually, this guy. Where are you? Oh, okay, that's fine. It should be fine. My lock, where is that? That's in 0 page. We're gonna need that. Do I have a 0 page segment in here somewhere? No, where the fuck? How? Right, I forgot about that. Sure, fine. Fine. Actually, no, not fine. Well, whatever. Enter my lock 35. Count. Enter my count 30, 36. Ready, 37. NMT update? I don't know if it's an NMT update buffer. That I don't think I care about. I gotta sneeze. Okay. All right. Thank you. Ah. Ah, man. What a mess today. Other variables, sure. We're actually gonna put all these into the 200 range. Yeah, they'll be fine. Probably. RQ? Okay, there's an RQ there already. Am I? Okay, do I have to do anything special for the enemy in this? Prevent re-entry. Is that a thing that is actually like needed? God, the mixing these two styles is something else. Put those in there like that. Am I ready? I don't think I need that. Because then it does a bunch of update crap specific to its thing. Actually, you know what? I don't think I even need that. The locking. Screw it. It's fine. It's fine. We're fine. Don't worry about it. That's other crap I don't care about. Palette stuff. There's a 0 page I don't really care about. Okay. Cannot open include file background churn. No such file or directory. Tile data, ink bin. That I shouldn't actually need to do myself, right? I don't think I need to do that. Constant expression expected. 1, 1, 2. Bypass. Main undefined. Right. Because that is instead reset. There's 2 of them. We are going to change that to main. OIM undefined. What? OIM. We don't care. Don't care. NMI undefined. And NMI. Because that is NMI. Make. Reset undefined. 167. Right. Okay. Yep. Fair. Like that. Invalid expression? Nest config 6. What? Missing memory RO data. Nope. Just nope. Oh, and that's actually okay. Let's see if that works. I don't think it did. I think I fucked something up. We're in the interrupt, but we're trying to bit 33. What the fuck is 33? Ready. Oh shit. No. Mains go over there. No. Okay. Let's go! Did that actually work? Oh my god! Holy shit. Okay, let's have a look at... well, let's get where we are again. And then debug, memory viewer. Did I already have one of those open? I already have one of those open, so let's go get that. All right. I want to have a look at... Let's read the vectors. So, from F0, let's just read those 16 bytes. Let's see if we can do that. So, that's going to be F, F, 0, start. Okay. 2, F, F. 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 Okay. Beautiful, actually. That actually worked beautifully. Okay. Progress. Now, I want to copy all of that to RAM and basically disable fucking everything else. Also, why are our sprites on? Hang on. Why the hell are sprites turned on? Sprites should not be turned on right now. Yeah, I don't actually care about sprites. You know what? This should actually be fine for now. Let's... Hang on. Okay. Hang on. Do this incrementally. It's fine. That. There. Ooh. For now. Where are you? That out. This is fucking monstrosity. Okay. Okay. This. Go. This. Okay. All right. So the wind, no, wine. Okay. Here. Add on. Please set discard. All right, we're going to load up. Oh God, I gotta fucking find it now. Hang on. I know you can't see what I'm looking at. Don't worry about it. It's fine. There and there. There. Disk trouble error 24. How dare you? How dare you? Eject. Try again. Why? What is error 24? Does anybody know what error 24 is? What is that? BIOS. Are they listed here? Error list. File header block expected. Did the bypass thing not work? Thank you for that file. Appreciate that. Cannot include file check.bin, no such file directory. Check.bin over here. Make. Okay. Let's try that again. Eject. Open. I gotta look for the damn thing again. Hang on. Give me a sec while I navigate to that file. I really need to figure out doing this without root, so I don't have to futz around with these directories like this. This one, this. Error 24 again. What the fuck? Setting the file count one higher than the files on disk for the license bypass technique. No, okay, it doesn't do that. Let's try that example.fds. Where am I? Code. No. There. Too many folders. Something ain't right. What the hell? Okay, we're gonna try adding these to the thing directly. Hang on. Code. God damn it. Yes. And then example FDS. And then add. My God, I gotta navigate all the way back there. Pain in the ass. Okay. Example. Fuck you, actually. Okay. No. Actually, that's mine. Without the bypass, fine. I don't care. All right. So, we want to have a look at F0 to okay, cool. It actually works. Neato. All right. Let's have a look at F. No, actually, we want to look at 5,000 to 5,000 0 0 F. Chicks, how you doing? Something so comfortable with looking at the bike. All right, what was writing again? Let's go ahead and break literally everything. Change the single member location for. Okay, so first we're gonna turn the LED on, and that's writing hex 80 to the address that we need to the register, right? Which I found out is a massive range from 4C00 to 4DFF, which is neat. But anyway, we're gonna use 4C 00, and we're gonna put 80 there. It turned the LED on. Awesome. 4C 00. We're gonna turn it off with 0 and then 0. Good. Okay. Oh, this is gonna be so painful. Okay. All right. Let me have a look at my notes real quick. Hang on. My notes of. Let me actually show you what I'm looking at here. Okay, so this is some stuff from yesterday where I was trying to verify some things in relation to RAM stuff, right? So I was able to remap the what's it? The upper bank, the E1000 up to something else. If I try that now, without preparing anything, I think it will 100% crash. Because I'm using the NMI, and if I remap that without accounting for it, everything will break. So I have to be careful. I have to be careful. That said, so on the dumper, I wasn't able to write anything to the 5000 range and read it back. I was able to write stuff there and read it back somewhere else. So if I wrote to 5000, and then with this right here, setting 4, that remaps the RAM to overwrite essentially the BIOS on the disk system, which is not something I want to do right now. But if I did that, if I wrote it to 5000, remapped it, and read from E1000, I could read what I wrote to 5000. But I couldn't read what I wrote to 5000 from 5000. So let's try writing or not. So we already have the printout of 5000. We're gonna write some stuff to 5000 and then read that back. Okay, so 5000. We're gonna write 0, 0, space 0, 1, space 0, 2. Okay. I don't think that did anything. Or it might have. Hang on. 1, 2, 3, 4, 5,000 to is this an emulator? No, this is hardware. I'm on hardware right now. I'm on this right now, right here. And I'm watching my capture to figure out what the hell's going on. All right, so then we're gonna read from that to 5. 0, 0. F. Start. Okay. All right. That does actually work. On hardware, but on the Famicom, not on the ROM dumper, though. What the fuck? How dare? How dare? So frustrating. God damn it. God damn it! I don't know why. I don't know why. I'm glad I was able to get this running though. So I don't know how far I want to take this with like the verification for things. I don't know. Because so for the verification, there's bytes that I okay. So there's 2 bytes. Hang on, let me bring that up over here so you can see it. Where the hell was that? Oh, I guess it. Well, no. What is this? Don't I have the disassembly stuff open somewhere? Yeah, that's this right here. Well, whatever, it's fine. It's fine. See there, Vim notes. Okay. This scene. Oh, what is this? How dare you steal my car? What? How dare you? Yeah. How dare you? How dare you steal that car? Okay, so this is the register for the Souseiki Fammy. The values up top are the values I have seen written to that register. 0, 0 clears everything, resets everything to normal, I guess, right? This is written before the jump to ROM. So it turns off the LED, which is this guy right here, and remaps the RAM, right? Remaps the onboard however much RAM to E1000 to FFFF, right? I'm not sure what the hell this is, but that happens a bunch, right? So that'd be disabling the ROM control, M2 control, enabling it there on disk. When which one was that? I don't remember if that was in the copy ROM to disk or if it was the disk to RAM. I don't remember which one that was. Disk sys, no. QD. Was it this one? 4C00. Yes. Okay. So this is the one where it's copying it from cartridge to the to RAM and then to the disk. So that decision is very easy for me. I don't have anything to eat here, so I have to go out and get stuff. So what the hell was I? What is this? Too much crap open. Yeah. A hot pocket in the freezer and a bag of frozen veggies. That's not a lot. Oh my god. So yeah, I basically want to be able to. I want to confirm exactly what these are doing. Let's just see if writing 4C breaks everything and crashes. Fuck it. Yeah. Let's just see what happens. What could possibly go wrong? 4 C. Shit. Nope. Four. C. 0, 0. We're gonna make that. Let's just write 4C. We'll write 0C. Or actually, no, let's write 4C. So this might completely break because I am unmapping the page that has the NMI handler. Pop. It crashed! Let's go! Oh, it crashed. I can't, right. I can't even reset it. The reset button doesn't do anything because that bank is not mapped in anymore. If I hit reset there, oh my god, that makes it worse. Holy shit. This is amazing. So that reset should have remapped that top bank. But it didn't, I guess. I don't know. That's funny. So what's that insane news you got? Next month. Identifying as a work printer. Discord. What's in what? Oh shit! Nice. Twilight Princess, 100% decompiled. Neat. After 5 years, 3 months, and 23 days. Wow. 1.2 million lines of code. Not bad. Not bad. So now, how do I verify the bank switching bullshit without breaking literally everything? I'm basically gonna need to. I need a routine that I can run that will switch bank. Well, we'll turn off the NMI, switch the banks, write the NMI handler, or copy it somewhere. Fuck, I don't know. So as far as I know, let me come over here. So as far as I know, here's the memory map, right? So from that to 7 FFF. That's our main RAM, right? Our system RAM, right? From 5,000 to 5 FFF. That is our Souseiki Fammy RAM, but only half of it. That's important because that means I cannot write the vectors before remapping. Right? Then we've got 6,000 through, what is it? DFFF. This is the FDS RAM. And then E1000 through FFFF is the FDS BIOS, or the SF RAM. All of it this time. So I've actually got a lot of area that I believe stays put, right? So this, I don't believe, is mapped anywhere into this. I don't think. Which means we can use that space for whatever the hell we want without fear of losing anything. Basically, right? Sure. Yeah. So basically, I want to write a verification program that I can put there. Run. I think I need to hit the bathroom again. Yeah. I'll be right back. Don't go anywhere. I'll be right back. Okay. All right. All right. So. What I want to do is I need... No. Main. Okay. So we're going to set that up right here. So we're going to load up 0. That should turn off actually let me hang on. So I don't want NMI to fire off, and I don't want IRQ to fire off either, actually. CPU registers control turn off NMI. Okay. Yep. So we're gonna store that into 2000 SCI turns off IRQ. SCIs turn off IRQ, right? Set interrupt disable. Yes. Set the interrupt disabled. Turn off NMI. Load up. No. Look, we're gonna load up 4C. And we're gonna store that into 4C00. I'm gonna load up low byte of NMI. Store that into that's IRQ stuff. Store that into A and B. Okay. FFFA. Yoink, paste. No. High byte. B and F. And then load up low byte main, store that into FFF C and D. Bye. Okay. And then that enables NMI down there. Okay, that's fine. So I can turn it off at the top and then just re-enable at the bottom. And if this works, I should just see the, what's it? The, yeah, the thing. Make. Turn that off real quick. Plug this back in. Like that. DS stick. Desmon, remove, add. Home, there, and there, and then. Nesmon, DS. Why? What happened? There, and then where is it? There, and then there, and there. Okay. All right, let's see if this works. Did it actually work? Okay, so if this worked, we shouldn't see anything at E1000, I believe, right? Okay, let's see if we can get 16 bytes at E1000. Let's see what that looks like. So that is going to be E. Oh, I need to turn off fucking sprites. E1000 to E 001. That's not what I meant to do. I wanted E1000 to E010. No. That's the wrong I needed the dot. I need the dot and the dot. So that's E. I'll get it right one of these days. 000 2 E 0 fuck 1 0. Really? Memory viewer. No, it did not remap anything. Interesting. So 84, hex 84 is written before copying to E1000. Maybe I need that instead of 4C. Let's try that. Okay. So I'm looking at this right here, right? So first let's turn off sprites. What the fuck is that again? (2001) mask. Three. And oops. That one? Yeah. Do I have the I do not. I need the hang on. Yoink. Paste. Okay. All right, so we disable sprites because we don't want any sprites. 44 04. Because I don't want the LED on. Cause screw it. That's I'm not sure what the others are doing. We're gonna do that. Write those. And just see what happens. Make. And God, finding these things is such a pain in the ass. Navigating to the folder I need is such a royal pain in the ass. Code. Okay. Okay, sprites are disabled, it looks like. So we're running the good code, I guess. Okay, so we want to have a look at E 0, 0, 0 through E 0, 1, 0. This looks uninitialized to me. Okay, so now we're gonna write some stuff there. E 0, 0, 0. I'm gonna write 0, 0, 0, 1, 0, 2, and 0, 3. Okay. And now we're going to have a look again. So E 0, 0, 0 through E 0, 1, 0. Okay. Now we're going to have a look at that same address, or what I believe to be the same address, in the 5,000 range. So 5, 0, 0, 0 through 5, 0, 1, 0. Fucking beautiful! Okay. All right. So that means that bit turns on that mapping there. Okay. What does 8 do? Okay, so we're going to turn that one back off. So we're going to write to 4, 0, no, 4C. C 0, 0. We're going to write. Went the wrong way. 0, 0. Okay. So now, if I have a look at E 0, 0, 0 through E 0, 1, 0. That looks like the BIOS again. Okay. And I should still see that that data at 5,000. Nope. No. Dot. I do. Okay. So, what happens if I write 08 to that register? 4C 0, 0 0 8. E 0, 1, 0. Still has that mapped in. Okay, what about 5,000? 5. Okay, so I'm not sure that that bit does much of anything then. Okay. Um. Okay. Stealth arching now? We are not. No. Hey, by the way, Somersault, welcome. So, the only bit we don't know what it does now is bit number 3. You know what the hell that does? I don't know. Actually, from what I remember, there was... Oh, well, no. Okay, so this changes... That's what overrides the physical switch for the ROM and RAM. ROM and disk, rather. So if I change that... I wonder if I can write a certain value here and get it to start running the cartridge that I have inserted. So that would be disabling the M2 control on the disk, enabling it on ROM, and disabling that map. And setting this, I guess. So what would that be? Thank you for the follow, by the way. I appreciate that. So onboard LED, we do not want that set. ROM M2 control, enable. Disk, disable. Disk PPU control, disable that. Unknown, we're gonna leave that alone. No that. PPU control, disk ROM. We're gonna do ROM there, and then ROM. 33? Just 33. All right, let's try writing 33 and seeing what happens. For C 00, we're gonna write 33. It broke. Oh! Okay. Okay. It's running the ROM without getting the PPU shit from the ROM, from the cartridge. Oh, that's hilarious. Fascinating. Okay. What happens if I just switch now? Ooh. Oh, I broke it. Wait. Really? Okay, that's weird. Switch. Yes, okay. So it does not like being switched live, number one. It doesn't like that at all. At all. Okay, so PPU, CRM, disk, disable disk, enable it. Disable disk PPU writes. Yeah, okay. Disk M2 control, disable that. We want to enable the ROM. Okay, let's try setting that other bit. So we're gonna write this right here, which is gonna be 3. 8. 8C? 3C? No, that ain't right. It's D. No. Hang on. What in the fuck? Bin 00111011 hex 3B. Okay, 3B. We're gonna write 3B and see what happens. Okay. 4 C 00. We're gonna write 2 3 B. If I hit reset, it jumps to this right here. So it's not using the it's not using that name table. Not name table. I mean what's it? The the CHR. What? Okay, let's do this. Let's have a look at let's have a look at the slow ROMs. DASM SF slow ROM. Bins SF slow ROM. Underscore. It's an underscore. Dot bin. All right, 2 files. One of them is a fucking, what was that, name table? I'll leave that alone. We just want file 1. Dot bin. Okay, so grab that, paste. Slow. Starting with the pre-copy. Yoink. Paste. I don't know what any of this stuff is yet, so we're just going to leave it as is. Why the fuck is that a directory? I broke it again, didn't I? God fucking damn it. Why did I break that again? Why in the fuck? I keep breaking this shit. Outdoor if output is not that. Okay. Side 0, file num. Is it 1? I don't actually want. Yeah, okay, file 1, yep. File number 1, output bins sf slow rom.bin. ROMs sf slow rom.fts. Outdir. Why the fuck is that an outdir? That's better. Okay. That's what I wanted. It still didn't do the fucking... Stop that. It didn't do this guy. Why? Fuck you. File 1 bin. File 1 bin. LS bins. Make. Clean. Make. Why? Why is it doing this shit? Huh? Slow. That's a slow ROM. Oh, because... There we go. Okay. So, this is this disk is the slowdown disk, right? So if let me actually demonstrate what that does. Here, turn it on. That is going to be this. Slow plus for ROM, right? So I'm going to load that up. Eject card disk. That button? Slow level by, sure. Okay. Start. Is it start select? What the fuck was it? Shit, how do I use this again? Hang on. Hang on. Hang on. Bubba. And then, okay. Supposed to QD. Supposed to ROM. Into the ROM. So okay. Once game starts, press start and select at the same time. Let me actually turn that, like that. So, hang on. I can't actually hear any of that. Because I don't have it as, give me a sec. Let's mute that. And then, properties, and I want, no. Audio properties, I want to. Oh, it is monitored. Okay. Oh, it's just very low. Okay. And it is start select at the same time. Okay. The screen freezes, then is now in still plus mode. The selecting this mode will slow the speed. No, that's not what I wanted. Hang on. Reset that. Was that it? Once the game starts at the same time, if the screen freezes, then it's now in slow plus mode. Pressing select on this mode will set the slow speed set earlier. Hang on. Nope. Let me reset this. Hang on. Let me try again. Give me a sec. Slow plus. Eject. Okay, 1/8 speed. Start. Okay. And then pressing select. No? Okay. Why the hell? That's what I wanted. Maybe not? I broke it. I think I broke it. Hang on. I think it's flashing LED too. So I should probably be paying attention to that. Eject. Yeah. Eject. 5. Yes. Yes, they did. Okay. Setting all this is initial value level. Speed can be changed during gameplay. After setting the speed, pressing the start button will immediately start the game. Once the game starts, press start and select at the same time. If the screen freezes, then it is now in slow plus mode. Pressing select in this mode will set the slow speed set earlier. There we go. Now it's slower. Okay, start. This is normal speed. This is the slow speed. Okay. Up down change speed. Up goes faster, down goes slower. Rapid flashing is faster, darker is slower. Right. Now hitting start. Normal. Slow. Not as slow as I thought it would be. Still, that is slower. Yeah, okay. Right. So, slows the ROM down while you play it, right? The way it does that, which by the way, I have disk selected right now. So, there is a way to get it to read the proper name table, the proper PPU stuff. CHR. There is a way. So we got to figure out how that does that. I'm going over here. Turn that off for now. That's a little loud for me. Okay. All right. So, let's see what this thing is doing. Back from quick nap. Yeah, no worries. Welcome back. Okay. EA1A. What the fuck? Controllers? Occasionally double read and apply external controller data. EA1A. BIOS. Read down pads. Read hardwired joypads. Detect up to down button transitions. Uh-huh. Read down to verify. What the fuck? Read hardwired pads. Detect up to down button transitions. Data is read until 2 consecutive reads. Oh. Read or. Read both hardwire. Hardwired pads. Detect. Huh. Interesting. All right, so that's read down pads. Let's get that in there. No. From here? No. I don't need this up one right now. There. Label EA 1A FDS. Read down pads. Make. E7A3. Really? Really? E778. Okay. E729. Nope. E6B0. What the fuck are all these doing? E6-4D. Nope. E492. Set num files. Write the number of files in A to the file amount block. Okay. What was that again? 492. E492. E64D. Unknown. Okay. E6B0. No, they're not sure. E729. These are branches and a fall through. Yeah, it's using these though. E778. Success exit? Okay. E7A3. Disk data byte fetch or restore? Enables IRQs and sits in an infinite loop. Contextually, this both reads and writes bytes. Presumably, the data direction is set elsewhere. Interesting. Whoa, none of that. Well, we are going to make some of these for them. 64D. Six BO. 729. 778. 783. God damn it. Or did I miss the... the hell did I miss it? It's on all of them. Oh, what did it do with the temp file? Fuck you! It deleted the temp file. Oh, God damn it. What? Oh, because that's O, not 0. Ha! FFC. What is that? Is that the reset vector? That's reset, isn't it? Yes. FTS vectors. No. Label. Adder. FFFC. Name. CPU. Vector. Reset. Okay, I don't think those are actually used none. E IRQ A and a MI. FFA already defined in Disksys? What? Oh, because those are, yep. Got them there. There we go. There we go. Okay. Okay. Thank you for the file. Appreciate it. Okay, this is going to be slower on this one. Okay. JSR over to here. 7806. What in the... No. No! We got a copy loop. Son of a bitch. Label. Adder. DFF0. Name. Pre-copy IRQ. C0 pre-copy. Reset. Pre-copy NMI. It's really the entry point. Pre-copy entry, pre-copy IRQ, and then this guy is the copy loop. So that's going to be range from start of df00 to end df1b. Type code. That name is going to be pre-copy loop. Pre-copy main copy. All right, so it does the copy, and then skedaddles down there. I don't think any of that's actually used. So we're just going to set data for basically everything else. So every single one of these uses the same goddamn snippet, basically, which is neat. All right. Where's another one of the pre-copies? Pre-copy config. Get rid of that. Make E. Wish there was some more new lines in here. So that's all the code and shit that's copied. Starting from there, the D800 right there. Which leads me to believe that that the other code, starting at what, D1000, is something else. That's like never used, right? Because like this copy is starting from D800. It's not copying from the beginning of the data. Oh, no, it is. Never mind. How did that disassemble correctly then? Because that's starting from D8, not D. Hey, don't look. DB, okay. Load 5, what the fuck? Wait, 5.8? Huh? What the fuck? Oh, is this mirrored or some shit? What the fuck? Hang on, that's actually in there twice. Right? Oh shit! Nope. I'm doing from the wrong. Make. Oh, disassembling the wrong thing. There we go. Okay. Oh, it's disassembling the wrong thing. That's what was happening there. Break. No, break is a it fires off an interrupt. But those aren't actual commands or opcodes. That's just data. Range start at DF F1E end at DFBF type byte table there we go. And there's much more of that afterwards. Start at DFE3, go to DFEF. There we go. All right, that's working better now. All right. Pre-copy, and then I'll need a. I'm going to need a post copy as well. Copy that to post copy. Pre-copy, post copy. Post copy. This guy is starting at 5,000. DASM, and then the post copy. Oh no, it's an official opcode. Yeah. But in this, when you're seeing it here, that typically means that's not supposed to be an instruction. That is supposed to be data, right? Saying that like these are probably not instructions that are ever run. They're going to be data, right? In fact, these are the vectors at the end. These guys. We're actually going to grab that, put that in the labels down here. Watch it break. It didn't break. Surprising. Missing a spider. Nope, 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 nope. Nope, 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 nope. Okay, so this is the pre-copy stuff. I don't actually care about right anymore. Um, 5.7F, and this guy is going to be 5.7C. There we go. 100. Like that. Did I not, oh, that's the entry. Come on, where's... That's that copy loop there. 559... So from there. I'm just going to ignore all that for now, actually. No. The blank state or FF, the programming process clears individual bits to zero, so you can take an already known PRG ROM and clear any random byte, break, or to add a breakpoint. Oh, interesting. All right. So this is the entry. Adder 5,000 name entry. Post copy entry. Okay. Load X, put that there to reset the stack. Load 0, store that in 5FFF. Okay. JS over to here. ASL at X offset. All right. Load A, and it. Hey, what the fuck? Branch equal. Load A and branch equal. Load A what in the hell? Some weird controller bullshit going on there? I did not know. I've heard of stuff like that, though. I didn't actually see that one specifically. Okay, so it's using some uninitiated RAM as storage. That's cool. It's not equal. Load 1D 4C00. Okay, 1D. What the fuck is D? 1101. Okay. 1101. ROM. Disk PPU. Enables the RAM and whatever the hell that other one is. Uh-huh. Load A, load X, RTI. RTI? RTI? Memories out to 4 bits. I should. But, I don't know. I'm too tired right now. So where the hell is this going to return from? Let's say this was 1D. Yeah, return from interrupt, which I didn't think it was in an interrupt at that point. That's the thing, right? So we're in the entry point here, which I guess that could be considered inside the interrupt. Let's wow. Ew. Souseiki Fammy, and then I want dumps. Slow for ROM. Add breakpoint. Execution at 5,000. Reload. Just try that again. Reload. Okay. We're at 5100. What the fuck? Why are we there? I thought the entry point was up here. What? DASM, slow pre-copy. Oh, shit. No, it jumps to 5100. Okay. So that's what the entry point is. I don't know what the hell that is. The entry point's way the fuck down here somewhere. What? God damn it. There's another one where it modifies that shit. Let's copy entry. That's an LDX. No. Huh? Wait, what the fuck? Why is that at 5,100? Excuse me? Why is that not at 5,000? Because it copies it to... Why? Why? I hate that so much. I hate that so much. Oh my god. Yeah, because now we're going to different places now. Jesus Christ. Disable drawing, wait for VBlank, to write all the shit. Okay. JSR over to here. Okay, that's the where is that? Didn't I had a name for this. I think. SF_FDS or something like that, right? I don't know. All right. So these are probably wrong. Those are wrong, actually. God, God, because now, oh my God. Yoink. Paste. These are starting at, these are 5.8. F6. These guys are incorrect now. So I don't want these in here. Those need to be in there. There. Does the copy the same data to many places? No, it copies everything everywhere. Using it's a free will. No, this is not my disassembler. This is the disassembler that's part of the CC65 compiler suite. So no, this is not my disassembler. Okay. Whoa. I'm just gonna make all this shit back here just code, or not code, just data. Pre-copy RQ, yeah. Pre-copy entry. It's no longer correct. Get rid of those. Make. All right, so from at least here, 5697. And we're just going to go all the way to the end for this, actually. Ending at 58F5. 58F5. There we go. Can't shoot football unless you have like 5 different expensive shooting services. That's sports for you. Okay. JSR. This is menu init, basically. Label. Adder. It's going to be 5.3a. That's not a 5. 5.3a6. Name SF menu init. That. Do a bunch of shit there. This here. Label. Adder 5.2b3. Name SFFDS reset. Then that RTS is goes over to here, does a bunch more shit. Load that. Range. Start 5.2E1. End 5.2E2. Type address table. Store that there. 5307. 6 and 7. Okay. Yep. Then it goes over to here. This is probably all data, actually. 1 and 2, so range. Start at 52E3, end 52F9, 52F9. There's probably going to be some screen data. Type byte table. Yep, it's going to be some data. Excuse me. Oh, I'm off by 1. FA. FA. There we go. All right. 90. Put that in 2. It's enabling V blank and some drawing bullshit, right? Whenever I've seen them work at football, I always hope they actually mean football and not just hand egg. Football, it's not just hand egg. Yeah, well. Wait for V-blank, write some RAM data. Okay, so this is drawing some shit to the screen. 5306 and 7. That, okay, so, yep. That is, like, some text or some bullshit. That's what that's going to be. 52 FB. Draw text. Jump over to somewhere else. Says scroll, enable FDF's reset. Through DA. Set draw done. So it goes there, does all that stuff, then returns from here. Load drive status, and it with 1 branch equal. Some delay stuff. Okay, this is for like eject, I think, or some shit, right? Yeah. If I do CD. Hmm. Okay, let me go here. Loadex, Dorex, Loadex. Increment, store it somewhere. Okay. C and D. 534C. And 534D. And this guy is going to go all the way down to there. 5365. From 534E, 4E. Of course it changes some shit in there. Of course it does. Foot is most of the time held in their hands. Ball is not round but weirdly egg-shaped. Hand egg. They use their feet a lot less than they do in soccer. So, read down pads. Okay. Hang on, where was I? No, from here. Then here, draw text, down pads, bracket side equal 4-2. So, what the hell? Raise you tennis. All right. Well, where's the 4C00? D. Okay. I'm not sure if that's actually in code, though, because not all that looks like code. I'll be honest. It doesn't look like it's jumped to either. 9D and 1D. Ew. What the fuck is this? That's not code, right? No, that can't be code. Actual football, if the ball even touches your hands, it's a foul. Unless you're a goalie, yeah. Unless you're the goalie. The only one allowed to touch the ball with their hands. Let's do this. I'll do that. Add a breakpoint. Every time we write to 4C00. Not that this is going to be able to do anything, but yeah. Go. Eject. No, I need to actually eject it from here. Eject. Set slow level. One. Okay, step back. Where are we coming from? ROM mode. That's all that sets. And nothing else. Then 0. Then 1 and 0. Then 1 and 0. 1 and 0. What the fuck? And 4. Is this in a copy loop? Yes. Okay, so this is copying the ROM to RAM and then back to the ROM, or kind of. It's copying it, yeah, from the ROM into RAM somewhere from 5800. Why the fuck? So weird the way it does that. All right, delete that. And zeros. Increment. Increment. Decrement. Branch not equal. Okay, so this is a copy loop then we're in. Store 4. 5.9 to FA. So it would have clobbered a bunch of shit down here. And comparing results. I don't think it's doing that. So here, in order to interrupt the NMI, it has to rewrite the NMI, basically, right? It rewrite the NMI vector. So what it has to do is it has to take whatever is in that hex E000 to F range on the ROM. It has to copy it into the RAM. And then once it's done copying, essentially, it would overwrite the NMI vector with its own NMI vector that does basically a delay and then jumps to the original NMI vector. Yeah. So this right now, it's copying what it would have copied from ROM, and it's copying that back onto itself, or back into the RAM at FA, whatever the hell, right? Add breakpoint. We're gonna do a read for anything that is E1000 to EFFF. Get rid of that. Settings, game, reload ROM. Yeah, what the fuck? I appreciate that. What the fuck is this? The data table is reading. Okay. Eject discard. Okay. Game. Eject. Set slow level. Sure. All right. Sets it to 1. And then load F1000. Store that. 5.7. Okay. Yeah. ROM. And it'll store that in 5.7. So this is basically going to be overriding the, or it's taking the BIOS essentially and grabbing that, which is fine. Thank you for the follow. Appreciate that. Appreciate it. The laugh is not. Oh, because I muted it a while back. You couldn't hear the music either. I muted it when I was doing some when I had the hardware running. That's why. I heard it. You couldn't. It's good now. Go next. 46. Okay. We're gonna put a breakpoint there. Bop. All right. Copy the page. Now, load 0. Store that there. RTS. Increment. Decrement. Branch not equal. Wait. Load 1. Store 1 back. Right. So we reset it so the NMI can run, and then after the NMI we copy some more. Absolutely. How you doing? Yes, this is assembly. Welcome. This is 6502 assembly. And now we copy some more. F1 to 5.8. All right. Copy another chunk. We might go all the way down to like here. I don't know. Then load it up 0, store that there, the reset, yep. Increment some stuff, branch not equal. The wait. Set 1 again. From F2 to to 5.9. From F2 to 5.9. Just give me 10 years. Nah, you don't need 10 years. Nah. I've only been doing assembly for 6, I think. How about 6? Okay. So I would have copied another one. This one here. Load 0, store that. Some increments. The NMI. Load that. JS over here. Set 1, RTS. F3 to 5A. Another bank. And hit 5B next. How many was this doing originally, by the way? They've got we got 5 more. So let's just hit that. Okay. So it copied all the way to 5EF. Really? That's 1 page short. I wasn't expecting that. I was expecting it to go all the way to the end. All right. RTS. From somewhere else. Decrement that. Branch not equal. Load X. Load Y. 5153. 5FE0. Increment. Branch not equal. Increment. Decrement. 57. 5740. Is that no. That's not one of the vectors. Is that one of our vectors? That'd be fucking... Where would that be? Overwritten, I think. Cool. No, it's D. Way over in D. C, D. These are our vectors here. None of those are what I'm looking at. Okay. Even though I'm watching this on 1080p, comparing to YouTube, the text looks slightly more crisp. Compared to YouTube? Yeah. So on Twitch, I'm actually throwing, what, like 3 different streams at it? I think? What am I throwing at it? Oh, come on, really? Hang on. Give me a sec. That one. Yeah. Come on. Is it authorized, you bastard? Really? Really? Disable that for 5 minutes. There it goes. Re-enable that. Reload. Okay. What is today? Today is the 21st. So yeah, I've got 4 of them going right now. So I'm sending, as you can see, I'm sending a few streams. I don't know if I want that session ID on screen. But I'm sending a 1080p, 720p, 480, and 360. I'm sending those from my encoding machine. YouTube, I'm just sending 1 stream over. Yeah. But yeah, I'm actually doing the encodes myself. I'm not relying on Twitch to do that. That was one of the big upgrades that I wanted with OBS, which is why I jumped through a bunch of hoops to get my stream machine updated. So I didn't have to rely on Twitch to, you know, give me encoding. I could just do it myself. Yeah, it's so nice. I'm so happy with that. So glad I can just do it myself. I don't have to worry about them, you know, having enough bandwidth or whatever the fuck. It's like, I have enough processing power for it. I have a dedicated machine to do all my Twitch stuff. So I don't have to worry about, like, it, you know, taking resources from a game or whatever the fuck I'm playing, you know? It's nice. It's nice. I like it a lot. No special hardware other than a video card, if you want to call that special, I guess. But yeah, just works, which is nice. Which is real nice. All right. Remember that. Branch not equal. Increment, decrement, branch. Load that. Store it there. 5156. Maybe I'll appreciate that. What the hell is 5156? So it stored some information up here earlier. I don't know what though. Okay, disable IRQs. Load. Store, load, store, load, store. Wait for IRQ. Setting 4. And now this is the copy the other direction. Okay. Can I benefit from having more than one graphics card in my stream PC? I mean, maybe. I'm not sure how well OBS will handle streams that way. It will handle. I'm not sure how well it will utilize the second card. I'm not sure it can. I think there's some synchronization stuff that it will choke on with that. I don't actually know. Not that I have space for that. I think I'm using up most, if not all, of my available expansion slots. Yeah. Oh, it changed these. Fucking. 5208 and D0. No. 5208 and 5208 and 520B. It just. Yeah. Okay. So that's the loop that it reset with. That's cool. Running multi GPU software is kind of hard. Yeah, that's probably why like SLI didn't really take off, right? I don't even think that the newer cards support that anymore, do they? Because you don't really hear anybody here, you know, doing multiple GPU setups anymore, unless it's for fucking mining or some shit, you know? Yeah, it's a difficult problem to solve, you know? All right, so that's gonna write a bunch of shit. I don't. Yeah, it's gonna go back and forth with that. But that was only the high. The high part of that bank, wasn't it? I don't know, because, well, Hang on. What the fuck is going on up there? Give me a second. It's a moving truck. Moving truck making all kinds of fucking noise. Oh, damn it. Ripping reality. Tore open reality. I think NVLink, that's why the successor, still supporting professional cards. Alright, yeah. No, that's but now you can do it yourself using the graphics APIs and communication happens over the PCIe lanes. It was moving? I have no idea. Tore a hole. Yeah. 5F E0. Wonder what these are. And that's more copy bullshit. Alright, what's one? Okay, where's it copying from? F8 to 5.7. Oh yeah, I don't need that right now. Okay, turn that back on now. Finish not equal with an RTS. Load, store, load, store. 8E. 8E54. 5480, sorry. What is that? What is that in here somewhere? That's gonna be our NMI, isn't it? Probably. No. No, that's something else. 548E. Do that. Yeah, not sure exactly what that's doing. Revolutionary travel. Yeah, right. That'd be nice. If they want, if I don't want to avoid the U.S. for now, they give me even better reason. Well, it's a piece recorded the last 5 years of phone number. Oh, I saw all that crap. Like, no, not happening. Not happening at all. No. Yeah, I can't wait for this regime to end. All right. 5165. Command. Load. What the hell? What the shit? Five one 4B 51A9. Deck 1 X does this twice. What the hell is all this stuff doing? Show how you doing? I hope he doesn't. Increment. Couches, yeah. I am gonna stifle just about any political talk, by the way, because I just don't want to deal with that right now. What is cooking? Tinspin, how you doing? I am reverse engineering some stuff, and I am deeply confused as to what is actually going on. Oh, doing some more copies here. I was back at the copy loop, 51E8. E8. This bastard is a copy loop. Range. Start. 5-1-E8. End. 5-2-1-D. Name. ROM copy. Make. What do you mean? What? Oh, type. I need to type. Code. God damn it. There's the, God, the, self-modifying code. So how have you been so focused on distracting the stream? I don't know. I actually verified some stuff on hardware earlier, which is weird. So originally for some hardware verification stuff, right? I started with the ROM dumper, right? Which is a nifty little board where I can plug a cartridge into it and basically interrogate the hardware, right? Mainly used for getting a ROM off of a cartridge. So you take one, you plug it in, right? This is an NROM, so it's a fairly straightforward one. Let's clean, right? Plug in USB to the computer, and just say, hey, copy from this memory address to that memory address, right? So I had this plugged into the Souseiki Fammy, right? Plugged into this thing right here. I had this upside down, right? With everything else plugged into it, the ROM as well as the disk system RAM adapter, which is the black thing, right? And then it started interrogating it, right? So I'd write some address, write the registers, and then dump a memory range, see what changed, write again, dump again, and it wasn't why. So I'm trying to verify how this thing works. As far as I'm aware, no one else has in the West, the English-speaking part of the world, has gotten their hands on this. So we're doing some research on this thing to figure out how it works, right? Welcome, by the way. How you doing? Murilo? Morluber? How do you say your name? Welcome. And basically, this device is a really weird thing that goes in between the Famicom and the Famicom disk system. It can take a cartridge and put it on a disc, and then we can play that disc from the cartridge. There's also, which is what I'm stepping through now, a slow-mo disc. There's a few of them, actually. So I'm sure you may have seen some third-party controllers that had like a slow-mo button or switch or whatever the hell. Oh, very bootleg, very. And the way that those would work, right, is that it would spam the start button every other frame, right? Which worked, I guess, right? But it spammed like the start menu, whatever the hell, would probably, you know, what's it? Spam the audio or whatever, make it sound really garbage, and probably wouldn't work very well for a bunch of games, especially for any game that like has a menu of any kind on start. Excuse me. So this does it a different way by interrupting the NMI. In order to do that, it needs to rewrite the NMI vectors, which are on the cartridge. The way it does that is it's got extra RAM in here, right? So what it does is it copies, or the extra RAM can overwrite a chunk of ROM essentially, right? It can remap it to be where that ROM would have been, the E000 to FFFF, right? So basically what it has to do is it has to copy what was there in the ROM to its RAM, then rewrite its NMI stuff, the vectors, and then remap that over, right? Really bizarre, but it works really well when it works. I haven't tried it on any weird mappers, because that's a possibility, especially any that bank switch the top bank. If that's not a fixed bank, that'll be interesting. But yeah, so we're having a look at this thing. And originally I was interrogating it with this device, writing a value to the register, seeing what changed, and for whatever reason, I couldn't read from the RAM from the hex 5000 range. But I knew that had to work because that's where the disks copy the code and then immediately jump to the code. This code that's running here is all running from the 5000 range, right? We're at 51 FB right now, right? And this is a patched version of Messin, by the way, that I'm running to actually run the ROM. It doesn't work because of a lot of reasons, but whatever. It works enough for me to pick it apart. So I know I'm doing something wrong, presumably. Yeah, that's the Lua stuff, right? Do I still have that open? I don't think I have that open anymore. I think I closed that. But yeah, so I could write to hex 5000, but I couldn't read from it. It just read back as FF, whatever I read, right? Big massive block of FF. But if I map that to E1000, I could read back what I had written to 5000. So, on the NestDev Discord, someone has ported the Wasmon, to the NES, Nesmon. Now, this expects to be used as, from a cartridge. I do not have a sacrificial Famicom cartridge. I do not have a rewritable Famicom cartridge. So I could put this on a cart and, you know, pop it in and try it and make sure it works. But I do not want to try and use my, what's it? My EverDrive with that, because that might interfere with things. The EverDrive does fuck with the IRQs. I know that. I have an adapter that all it does is it disables the IRQ from the EverDrive, but I don't know if it'll do some other weird shit, right? Because this pulls some shenanigans, right? So I thought I was stuck for a minute, being like, oh, I can't get anything on here then. Wait, I have a Famicom disk system. Let me just put it on a disk instead of a ROM. So I did. I figured that out. So I now have that. That is this guy right here. So this is Nesmon running from the Famicom disk system. Ta-da! So here, these are both NES and Family versions of the EverDrive. Yes, I have the NES version as well. It's not the Pro version, but I have one. I haven't used it in forever. But yeah, so now this is Nesmon running from the disk system. So now I can interrogate the disk system. And in fact, and the Souseiki Family. And in fact, this, as it is right now, I have mapped out, removed the disk system ROM, the BIOS, and patched it so I can still view this with the NMI and all that kind of crap. I had to rewrite the vectors so this would work, right? So if I have a look at E0 through E010. Oh, that's not what I want to do. I want the dot. The dot, because that's read. Oh, it's a pain in the butt to actually enter anything though. E010. That is uninitialized garbage, right? But if I have a look at F0 through where is it? F 61E2 605B 61E2. Those are my no keyboard. Nope. Those are my proper vectors. I'm not sure what the other bullshit is because I don't want to copy it over there or if I copied anything. But yeah. I thought about maybe patching in keyboard support. I think Ninja wants to get keyboard support in there. I think. At any rate, though, this has enabled me to confirm some stuff on hardware that I can't confirm, or I'm having trouble confirming with this. Yeah. This is Barbie. Yeah, got a Barbie shell on it. Find the Family version. Find the Family cartridge connectors to be far more reliable. Haven't used the damage thing yet. The damn thing yet. The damage. I have my NES is collecting dust. I haven't turned that thing on in like 2 years. I even bought. Hang on. Let me. Collecting dust. I even bought one of these bastards. It's a connector that doesn't rely on the traditional like push down bullshit. It's a straight in connector, right? So it's just a card edge. In theory, more reliable. I got that well over a year ago. I'm not even sure if I tested it. It's not even screwed in. I lost the screws to this thing like 2 decades ago. It still works. I don't have any screws for it though. At least it should still work. I don't know. I haven't tried it in a while. No. I haven't tried in a long while. But anyway. Yeah. Lost my antenna screws too. I lost mine years and years ago. I want to say at least 20 years ago I lost them. I don't even know how long I've had that specific NES. I don't remember where or when I got it. I just know that I've had it for a very long time. Maybe around college, pre-college, I don't know. It's been a while though. It's been a long while. I didn't grow up with it. I got that after the GameCube. Yeah. In the bottom of the case, yeah, and that one, I took that apart long before I figured out to, you know, put the screws in the case so I don't lose them, right? So that's where those are. I must have asked before, but do you have any Commodore 64s in working condition? I do not have any Commodore 64s. So no. What was my first console? Game Boy Pocket. Game Boy Pocket, like when I was fucking 10 or something. You don't dare power up. Bad caps or something in it? No? Something grounded that shouldn't be grounded? Shorted out? That's the word I was looking for, shorted out. Did I get Pokemon Red or Blue? Blue. I think I still have that somewhere. I don't. My brother might have the game, but that battery and the battery in that died years ago, I think. I'm sorry, Tinsman. Blue Players Rise Up. Eric, how you doing? I also had a so I remember playing Blue so much that the hours rolled over, the hours played on the save hit 99, and then when it rolled over, it deleted my save. I was so mad. I was so mad. At least I'm pretty sure that's what happened with that one. Then with I had a Pokemon, not yellow, but shit, silver. No. Gold. That's what it was. I had a Pokemon Gold cartridge as well. Mauser. The PSU have is original, and those have a known failure mode that will badly overvolt the motherboard. Oh, frying some of the stuff. Gotcha. You can tap anyway for Game Boy cards to use some. Sure. Yeah, I know. I've replaced them myself. But for the gold version that I had, the battery died fucking decades ago. I'm talking back when I was in fucking middle school or high school or some shit, right? Well before I knew what the fuck I was doing with anything, right? So I remember I was so pissed off that I lost the save and it wouldn't save anymore that I took a hammer to it. I smashed the thing to fucking pieces. No, I haven't played the remakes. I don't have a DS. Well, I might have a DS, but I don't know what the fuck it is. I haven't used it. But no. I can't like bring myself to actually play them anymore. Cause I just find it too grindy. I just find those games way too fucking grindy. Like, it was fine when I was in, you know, fucking high school or middle school or whatever the fuck, right? But now I can't. I get bored out of my mind too fast with all that grind. Different era. Yeah. No, not even like a different era. It was like I had different expectations. That's not really it. It's more grindy than Valheim, in my opinion. All right. With Valheim, at least I can like build shit and you know, decorate or whatever the fuck and explore. Pokemon is oh, I need to get this guy out to level whatever the fuck so I can not get my ass handed to me in this gym. Let me go walk around in the grass for 7 hours and get 2 XP every battle for this guy. How you doing, by the way, Kenpai? Welcome. Plays factory games. Again, that's a different kind of grind. There's progression there. It's not walking back and forth, pick up thing, set down thing, pick up thing, set down thing. It ain't that. But the Pokemon games is, I'm gonna walk back and forth in this grass for hours so I can find a shiny, or, you know, so I can level this guy up. Oh, I ran out of fucking PP or whatever the fuck. I need to go heal. Fuck out of here with that. This program's assembly. Y'all are missing the point. All right? Every single one of you missing the goddamn point. So finish my language. Yeah. Join the club, apparently. Oh. It's just we no. I ain't got time for that shit. Is progress though? It is monotonous progress. It's monotonous progress. It's doing the exact same thing to make number go up a little bit. Right? But it takes fucking forever to make number go up. It's PLB award. That one I'm paid for, okay? That one's different. All right? If I was paid to fucking play Pokemon, that'd be a different goddamn story. Be a very different story. I'm not playing the play. I'm not paid to play Pokemon though. All right. Okay. Made it worse. God damn it, son of a... I can't see what you're saying. I'm blind without these on. Legendary XP share. Which is just a hacky patch for dog shit gameplay. That's what that is. All right. So that's the source. Label. Adder. 5208. Name. SF. Copy. Source. And then 520B. Copy. Destination. Guy's blind. Any new finds? Welcome. Oh, you can't even see what I'm looking. I'm looking at this. I was fucking on with this just now. This, by the way, is Nesmon running off of FDS, not off of a ROM cartridge, rather. So I can actually run it without using my EverDrive on hardware. And I have confirmed. Let me go back here. I have confirmed this guy right here, enabling the RAM. I'm not sure on this one yet. That is used, I believe, in a few places. Yeah, it is used. But I'm not sure why yet. Because this code is, holy shit, painful. We're trying to debate Pokemon leaving one half-finished products in a language that I'm doing for art design. Okay. Analog behavioral modeling. Oh. All right. Nice. Yeah, the code I'm looking through now, by the way, this code is the slow-mo code for cartridge, for ROM. So basically, the way that the slow-mo code essentially works is it grabs all the data from, I believe, all the data from E1000 up, copies that to RAM, and then recopies it to itself, kind of, sort of. Yeah, it does some shuffling around. Yeah. But yeah, so I did patch your Nesmon to actually load as. Did I close it? I might have closed it. Yeah, to load as a FDS ROM disk, whatever. Yeah, so I have it building an FDS disk. And I used it's just like copy pasted from this right here. This is the FDS example from Brad. Publisher source today? Oh, of this? Do you have a version that allows me to use the keyboard, by the way? The pad input works. Oh my god, it's painful. Your disk image is usually headless. Why? Usually headless. Why? How dare you? Oh, writing a language. Not that I know anything about that either. Yeah. Mm-hmm. But yeah, so this thing does have a way to switch from the disc to playing just the ROM. So I tried doing that with Nesmon with varying levels of success. Here, let me actually show you. So let me get my notes for. Was it this one? Yeah. Okay. I think it's like 1D maybe. That's not what I wanted. I want this one. Okay. Okay. So I'm gonna write to 4 C 0, 0. We're gonna write 1D. Yeah, we're gonna write 1D. 1 D. As you can see, that didn't really work. I'm gonna hit reset. Does nothing. Reset on that. Okay, reset over there. But I'm locked up. I'm frozen. Cool. Okay. So not 1D. Neat. Wish I design was more forgiving as software. I was just forgiving as software. Trixie, how you doing? Change one teeny tiny transistor size in Cat Valley, and suddenly my freaking amplifier is dancing harder than me. It's an oscillator. Keyboard support is in the updated version of the original last month board. Oh. Oh, yours is a fork, isn't it? Wait. Huh? Forked from. There it is. I know you can't see what I'm looking at. Joypad controls have been removed. A fork that uses joypad controls can be found over there. Oh. Oh. Huh. Yeah, not your fork. Yeah. Doesn't look at here. Why can you fork code but not a spoon or knife it? An imperfect version of the test program can be run by entering the following code. Of the test program? R is run, right? Let's got this up too. Yeah, R is run. Okay. Yeah. All right, let me 3B maybe? Or no. Let's see if we can figure out all right, so I want disk mode, right? Let's yoink that. Paste. I want disk mode. PPU, I want that from the disk. I don't want to enable these things. I don't think. I might want to enable this guy, whatever the hell that is. Disk PPU RW control, I want to disable that. Disk M2 control, I also want to disable that. ROM M2 control, I want to enable that. And I do not want the LED on. Yeah. Or even spork it. Uses as a fork, uses as a spoon. So that was 33. Okay. What happens if I write 33 to that register? I've also found out, by the way, if I write to 4C and CC will work fine. That's also the same register. So we're going to write 3, 3. Reset. Reset, and now I'm in that code. This is Donkey Kong. Believe it or not. It's just that, like, you know, it doesn't have the PPU on there. Turn it off. Turn it on. Okay, so this doesn't give me the PPU. What would that do? And that's fucking... That's B. 3B. I think I tried this one, but I don't know what happened with that one. So Nesmon. Hey, what the hell? Appreciate that. What the heck? What do you... What? No. I've already got it working, so I'm not ordering cartridges. Maybe so hard to play with today. Ooh. Banana Pi M20. Single board computer that nearly the same hardware as the NES Classic. Oh, nice. I appreciate that. All right. Let's write to 4 C. We're gonna write 3B. 3B. Oops. Reset. It is possible though, because the slow-mo does it. Four. Would it be just 1? Or 10? Maybe? Never did this. Oh, it doesn't. This is a special hardware. It does not. All right. So let's write 10. For CCC. Reset. Comes right back here. Okay. So that didn't do it. But I'm not crashed. Oh! Freshwater Fern, how you doing? Welcome. Welcome. Again, we're gonna have to figure out what I need right there. Hello. So I know it doesn't look like much, but I'm reverse engineering a bit of hardware. This guy. So I've got a Famicom disk system, a cartridge. Oh, let's get this out of the way. A cartridge. This is Donkey Kong 3, the Famicom disk system RAM adapter, and a disk system emulator thing. Don't worry about it. And then this weird piece of hardware. This is a Souseiki Fammy. It allows me to take a cartridge and dump that. Come on. To a disc, and then play it off of the disc. That's one of the things it can do. Another thing it can do is slow-mo for a game. Other slow-mos, other implementations of a slow-mo. In fact, I might actually have one somewhere. But it's like a switch on a controller, right? Where it's where you know, a little switch to turn on slow-mo and a little dial maybe to, you know, for how fast. And the way that those work is it just spams the start button, right? Which is kind of garbage, honestly. Because it'll spam like whatever the start menu thing is, right? The pause or a menu or what have you. Can I dump to the emulator? No. No emulator supports this hardware yet. What I have in Messin is very hacky and doesn't actually work proper. Assembly, yes. But so the way that this works is this thing has a little bit of extra RAM inside the hardware. So it is able to replace a chunk of the cartridge with its own. Now that I'm thinking about it, Well, yeah. So it replaces it with its own RAM, and then has its own NMI handler, which does the slow-mo a lot nicer. And now that I'm thinking about it, I bet you there's a way that it splits the RAM. I wonder if this is enable RAM at hang on. Is that what that is? So that's just 8. Okay, so we're going to have a look at no, we're going to have a look at F. F00002 F00F. Okay. I just saw you drop that. I know you can't see my screen. Nice. Get distracted. Foot long circle. How you doing? Welcome. How long my hair? Yeah, I got a cut a trim not too long ago, so this is only about down to like here. All right, it's not that long right now. I got it cut back at Thanksgiving. I got 6 inches taken off at Thanksgiving. 652 is the only number you know. Oh, nice, nice. The ROM does that. Yes. This can absolutely be used to dump discs, and I've done that. To dump and to write. I don't think I've written any yet, but yes. Yes. The tip level. Monodono, how you doing? Welcome. Okay, so let me write. First off, we're gonna write zeros to 4C. This is that register. The register that controls the Souseiki Fammy. All right, 0, that clears it, resets it. And now let's write 4C. Whatever, doesn't matter. That the last two don't actually matter. And we're gonna write 0, 8. So that should just set the high bit. Oops. Okay. And now we're gonna have a look at F000 through called mermaid length. Mermaid length? What? I do not have the patience to keep clean shaven. I can't. Comes to follicular hair transplants become viable. All right, so from there to F00F. Okay. Can I write to there? So we're going to write to F000. And we're going to write 00, 01, 02, and then 03. And then we're going to have a look and see what's there again. F000 through 00 F. It did not. Okay. All right. So there goes my theory. Still want to get rid of some. Yeah. So I also okay. Right before jump to ROM 1.4. It's also rating 04. Yeah. Before copy to or from, I forget which. Hey, doing Files, welcome. Trying some hardware verification and a little bit of reverse engineering. It says 4 writes 2. God damn it. And trying some hardware verification on console. Not with my ROM dumper, because I'm having trouble with the ROM dumper where it can't read from RAM, like, at all. DeMarcus, hey, well, not at all. From certain addresses, which is really weird. Oh, no, here we go. I'm not actually using Lua here, though. No. Damn, headphones are fall across my face without asking. I'm figuring out what the fuck your schematic actually means for software people. No. The register bits, yeah. I've had a text file with some analysis based on. Okay, let's have a look at that actually. All right. This file is intended to contain my notes on the, how it's going to be what it is. Jojo, thank you for 82 months. Holy shit.
He's the most powerful hacker of all
Appreciate
time.
that. Still working on bits 2 and 3, but it's progress. 2 and 3.
Oh, it's that time of the month again?
Yeah. So 2, this guy, enables RAM at E1000. But it doesn't disable it at 5. I've confirmed that on hardware. It does at least that. It might do more. I don't know. 82 months is a lot. Does that mean they give? No. No. Ah! Bridgewater, thank you. Bridgewater, what are you doing? Thank you. Thank you for the 5 gifts of subs. Appreciate that. Thank you, thank you. Yeah, was it in a little more depth than is easily included in the schematic itself. Not every unit in the schematic is tricky enough alone to avoid the super section. This is sure. First, some basic general information about the rules conventions. Basic Boolean operators history and precedence. Foot longs ago. Thank you for the sub. Appreciate that.
He's the most
Thank you
powerful
for
hacker
6
of all
months.
time.
Holy crap. Parentheses regrouping. Overline unary negation. Whoa. Why did I jump like that? Damn it. Boolean and, Boolean or. I just say something is a turn operator, which means if I then B, otherwise C. Objectives is used for the dip switches, or dip N. Yeah, okay. Roger implies M2 is high. All right implies both M2. Both the M2 is high and that CPU RW is low. EN represents whether the pin on the expansion character is linked to pin. Okay. ROM cell signal coming from the console is constructed by a NAND gate on A15 and M2 signals, thus. Okay. A lot of this is going over my head, by the way. A lot of it. My dip switches are all set to on, right? Yeah, okay. All my dip switches are on. Look at the single logic file all the way to the analysis file. Oh. The analysis file. I saw a text file, so. Oh, analysis there. Okay. My higher level analysis of the circuit, what I've already figured out about how it works, what switches and the register bits do, etc., along with enough low level details to explain how. Work in progress. Yep. Maybe useful to refer to schematic and signal logic text files. Details herein. So no, unless otherwise mentioned, this text assumes that the dip switches are all on. Okay. And that there is nothing connected to the expansion port in the back of the Fammy. Similarly, unless mentioned, it assumes that the register is clear, all bits 0, like on power up. The reset switch, all it does is clear the register. I found that out, yep. As well as send the signal to the expansion port, pin 17. The way it is wired also allows the expansion port to trigger the reset. Yep. I've noticed that it doesn't, I don't think actually it will reset the console. So I hit reset. Yeah, it doesn't reset the console. Right. If I hit reset on the console, it resets the ROM, right? Okay. Dip switches. The normal default state for all the dip switches is on. General impression I get from them is that they are intended to let an expansion device take over certain parts of the address ranges used by the Fammy and to control when certain parts of the Fammy are active. There are 4 pins on the expansion port that are each linked to one of the dip switches. For clarity and brevity, I have named those E1 through 4 with the number of corresponding to the relevant dip switch. In reality, E1 is pin 38, 39, 29, sure. Dip 1. Okay, I think I'm going to skip past these. Maybe. When on, E1 is an output of that. When off is an input. Okay. Yeah, I'm going to skip the dip switch stuff. Register. Register is write only. Cannot be read back. I found that out. Normally the register is mirrored across the range. It is. I have confirmed that. However, if dip 1 or 3 are off, this depends on what is connected to the expansion port. If anything, while E1 and E3 are high, which they are if nothing is connected, register writes are disabled. Huh. One functions for each bit of the register. Bit 0, when set, the meaning of the disk/ROM switch is turned around. Quite literally, it swaps which side of it has a logic high. Oh, so it's really just a switch, a flop, an inversion. Invert the hardware switch. Right? Bit 1, when set, the Fammy swaps which slot controls the CI RAM, A10CE, chip enable, and which slot receives the PPU A13 from the Famicom. The other slot sees it always as high. To do on these. Yep, you can boot from a ROM cart and software switch the disk to disk mode if you want to. Bit 4, fake ROM mode. When set, the Fammy pretends that most of the FDS's RAM is actually ROM. What the hell is this? Oh. By disabling the disk IF connectors, PPU, is that right? Signal, and unless the address is within that range, it's CPU read-write signal. That is also used by the Fammy's SRAM. Note that disabling those means writes are treated as reads, which likely means that bus conflicts become an issue. Bit 5, swaps whether or not the disk IF connector gets the M2 clock. That's controlled by the disk ROM signal. This inverts it. Another inversion. Okay. For the ROM. And then bit 7 is the LED. Now. So it's also rather the expansion port, pin 36. Oh. So, is that RAM also in the 6,000 range? Is it mapped to 6,000 whatever? And ROM, the target cartridge mapper has bus conflicts but are irrelevant basically. Yeah. So, okay, let me do this. Go over here. And then I want to write 040. 4C. Zero. God damn it. 4. Okay. Now I want to write to 6,000. Or let's just see what's there first. A5. Okay. Yeah, I think we're fine writing something there. 3, 4, 5, 6. And let's write 0, 0, 0, 1, 0, 2, 0, 3. Okay. Have a look at 6,000 again. Uh, 6,000 through. Through 6, 0, 0, 7. Okay. Now I want to have a look at F 0, 0, 0 through F 0, 0, 7. No. Okay. Wasmon? Yeah, this is a Nesmon essentially. Takuika, am I saying that right? Takuika Ninja in chat has written this. Yep. That covers the Fammy's RAM. 5 FFF plus the low part. 6,007 FF of the FTS's RAM. IPC dot, how you doing? The type you need a game controller, like you can, like you can't use a keyboard. Yeah, keyboard isn't implemented right now on that. 8,000 and up range, in which the FPS has both RAM and ROM, gets turned read only. Hardcore mode, yeah. And Fammy, I assume, means Famicom. Not quite. So this device right here, so this is the Famicom. This Famicom disk system. The disk system's RAM adapter, a ROM cartridge. And this guy right here is the Souseiki Fammy. What the hell? Souseiki Fammy. Some weird hardware that we're fucking with. I need to refill my drink and get something to drink. I'll be right back. Don't go anywhere. Alright, I'm back. I'm back. I'm back. Alright. So the Famicom is a separate device that docks to the Famicom. Yes! So it is a weird pirate device kind of thing. So one of the things it can do is it can take the cartridge, only certain ones. It has to be under a certain size, essentially, and it can't have any weird mapper bullshit going on. But it can take that and it can back it up to a disc. And then you can play it off of the disc without the cartridge, right? That's one thing it can do. The other thing you can do is it can do slow-mo for the cartridge, or any well, I don't know about any FDS game. More like any dumped ROM. Or, well, I don't think I've actually tested this yet. No. I want... nope, not that one. This one. For cutie. All right, oh, so maybe, quote-unquote, any game. Let's try that, actually. Hang on. Yeah. 4, quick disc. All right. Eject. I've ejected. Set slow level. 4. Hang on. There. This will work. Probably. Start. Set disc card. So what is it? Select start? Did it work? It might have worked. Oh, it absolutely did. Oh my god. Just start. Now we're in normal mode. Can I get that? Oh! Let's go! Well, that's a poison one, isn't it? I don't want that guy. And then select. Select. I'm in slow-mo mode. Oh, even in slow-mo mode, I'm still terrible. How? I don't know. I don't know what the fuck I'm doing. That's how. Yeah, I know. Yeah. The slow-mo would screw the status bar split. Oh, that's true. Did I see some weird happenings there? Oh my god, look at that. That's funny looking. That's what does that look like on TV? Not any more readable. A lot more flickery actually on the TV. Beep-boo, beep-boo. Yeah, the music is playing really slow. It's still playing like in tune or whatever. What? Come on. Broop, 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 broop. Oh, you can hear this, can't you? Hang on. Let me mute that. Turn that up a bit. Beep boo, beep boo. Ah! What? Whee. I made it. Good. Surprised it actually works. Yeah, I know it's part of the CPU. Yeah, but sending the new notes, yeah, it's slowed down. So, yeah. Yeah. Anyway, we're gonna not screw around with that anymore, I don't think. Power that off. Eject that. By the way, for my notes so far, bit 2 enables the Fammy RAM in the high range, E to F, while bit 3 determines whether that covers the entire range. Bit 3 goes 0, or just the F range. Bit 3 is 1. How do these bits also control several other signals that I haven't fully mapped out yet? I'm expecting the least part of that to be disabling the FTS ROM in those areas. Possibly. Let's power this back on. Wanted. Please hit discard. Yeah. Whoop, that. Give me that. Nesmon. Oh, I don't need audio on that anymore. Play back on this. Just the F range would make sense for the slow ROM plus, since it needs to overwrite the NMI vector. Right. Yeah, that's what I was thinking before. Like, so if it maps the entire thing, it has no more room for the NMI vector, right? For the actual NMI code, right? Which would also make sense why it only has half of the available RAM space in the 5000 range, right? So if we, so yeah, enable the RAM, and this could possibly be just high. So if I map that to C, which I have seen it being used, that would mean that I see the the BIOS ROM at E1000, but RAM at F1000. Right? Let's test that. Over here, so let's write just 0C. Yeah. For C. We're gonna write. I went the wrong way. 0 C. Okay. And I'm gonna read E 1000 zeros. No, not D. E 0 0 F. Ah. Right. Is joining the RA force? Kinda. So it's a group effort. Group effort. I have the hardware, so let me bring up some stuff over here. I have the hardware, so I was able to trace out where a bunch of traces went, especially underneath chips, right? The invisible ones underneath the chips. The red lines are on top, yellow lines are on the bottom of the board, right? So if we go to the bottom board, you can see the yellows, and then those reds over here are underneath the chips, right? I was able to do this to figure out what the fuck any of this means. Way the fuck over my head. Way over my head. Etterfaus has put together the schematic. This guy here. Let's pull that. Here. So Etterfaus has put this together. I am clueless in this program. I know how to make a mess. That's it. Yeah, it's all 74 series logic and a RAM chip essentially. Yeah. And Ninja is more familiar with the disk system than I am. And I'm using the Nesmon that they put together to help poke around. And what I'm doing is I'm reverse engineering the code to figure out what it writes where, essentially. But yeah. It's just such an excuse to buy weird hardware. You're not wrong. I needed very little convincing, to be fair. As soon as I saw that this was not a bid and it was just a straight buy, I'm like, oh, absolutely, let's go. But yeah, so I have so much random weird hardware for the Famicom, right? This is only my latest acquisition, which I'll be clear, I'm not keeping this. I am giving it to someone in the community that wanted it first and foremost. Yeah, we're all attacking from different angles, working on the same project, right? But yeah, so I've got all kinds of weird hardware, right? Like this is my other main reverse engineering project, which is the study box, the tape drive thing for the Famicom. I have a few of them. This is my second one. This one's actually broken, not because it's in pieces. That's not why it's broken. It's broken because it's throwing an error message that I didn't think was enabled. Actually, it's throwing an error that I didn't think it was able to throw. Put it that way. I gotta figure out what the hell's going on with that. I've also got a drawing tablet somewhere. I've got a trackball, other weird controllers. I've got a dance pad thing. Yeah. But yeah, so this is I'm reverse engineering a new piece of kit. I'm learning how the disk system works along the way. So I got new emulator / dumper hardware for the discs, which is nice. But yeah, so my main angle has been looking through the code and seeing what the code is writing, right? And these are my notes for that, right? So these are all the values that are written in the code. This one, I mean, is like reset, right? Written on the slow disk, after selecting speed. So this is one that that's written like during the copy loop, or inside of a copy loop, kind of, sorta. Before copy. Was it before copy? It was before a copy. I don't remember which direction it was. Those seem to be opcodes. These here? No, these are writes to a register. These are writes to the register controlling how shit's mapped, basically where the RAM is. And this right here is the loop that does the actual copy, right? Maybe that's the copy loop there. Where is that JSR? Is it this one? Yeah, that's the one that actually writes the register. I should put a label on it. 5161. Label. Adder. 5161. Name. SF. Right. Reg. And then this one, 6F, 5F, 5F, clear reg. What? Oh. Yeah. Figure out the register bits by throwing custom code at the hardware. Yep. Checking what they do in effect. Meanwhile, I've been figuring out the same bits from the hardware angle, looking at what bit values actually affect the hardware, so we can compare notes afterward and hopefully get something useful. Right. Right. Yeah, and I'm verifying that, you know, everyone else's notes, you know, check out on hardware, essentially, right? A lot of trial and error, a lot of staring at code, being like, "What the fuck is this?" Like that, and self-modifying code is fucking everywhere. It's absolutely everywhere. That's just weird notation, by the way. So this copy source, right? So load a value, put it in the source variable, right? Where's that source variable? Oh, that's just 2 bytes after this load instruction. It's the high byte of the address for the absolute address value in this LDA opcode. So we're modifying that directly in code and then executing it. So it does that for both the source and the destination. D0. That's a counter. Why that on loop counter? Way out in the middle of fucking nowhere. Label. Adder. 5FD0. SF loop counter. ASCII's all over the place. Wouldn't be hard for me to make a mistake and end up with completely wrong theories. Validating on hardware is an important step, right? Could the bit banks its own bytes? Pretty much! Yeah, pretty much! So, by the way, you'll notice that this file name is post copy, right? So the Famicom disk system is used to, well, load all this shit. This all comes on floppies, right? They're And I have those as well. These guys here. It comes on these, what are these, like teal? Cyan? Green? I don't know. I don't know what kind of color this is. Greenish. It's close enough to green because my green screen filter's taking care of it. Comes on these floppies, right? So it's loaded into the FDS RAM somewhere, right? In fact, it's loaded into, this particular one is loaded into D800, that range, I think. ROMs, SF, slow ROM. Yeah, so that's loaded into D800 to E, well, DFFF, essentially, right? That's what that's loaded. But it doesn't run from there. Oh, hang on. Nope. I need to go back in the case before I ruin it. Okay. Right, so it's loaded there, but it doesn't run from there. It runs a little bit from there, and what it does run isn't much. What it does run is it goes into here, resets some shit, resets a bunch of shit, right? Then memcopy. Right here, just copies a bunch of shit from D800 to 5100 and goes to town, right? Then it jumps to it. It just jumps to it, which is up here. No, what? No. What do you mean it didn't find it? Oh, because I renamed that to something else. 5100. It jumps to it. Yeah. Yeah, they are not 2.5-inch floppies. They are 2.8-inch Mitsumi Quick Disk floppies. Now, the copying is the first thing it does, right? Yes. Kind of doesn't just load into the 5,000 range to start with. Does it? I don't remember. I think it might. It might. But yeah, it doesn't do that. Maybe because at the time that this was made, they weren't aware of that. Maybe, which I don't know if that makes much sense because it's using a bunch of Famicom or FDS. What's it? Routines that we don't have documented, I don't think. Seem to recall seeing a file being loaded into the 2000 range even. Those are destined for the PPU. Even though it says code, it's destined for the PPU. There's checks in the BIOS for that I've seen while I was stepping through it. So yeah, it'll check for that and write it directly to the PPU instead of trying to write it to CPU space there. Yeah. Yeah, that's this right here. So that's PPU stuff. They knew the license screen bypass at that point. That's true, because yeah, we're bypassing it. No. Just without 2000 especially yes. Yeah. So this should have well, not should, it does have the tiles in there. Alright, so it would have loaded up these guys right here. Or Kali Linux 28. Hmm. The BIOS flaw should have been preventing the loads below 6,000. Well, for the 2000s, I think there's code in there specifically checking for the 2000 range, specifically, so it throws it over to the PPU. I think it's been a hot minute since I've actually looked at it, and I haven't done a full disassembly of the BIOS. I mean, I have the BIOS disassembled, right? I don't have it annotated though as to what everything's doing. Or what's data versus code or any of that kind of crap, right? I don't have any of that stuff mapped out, which I might want to do that eventually. Yeah. I thought the phone would get fixed and decided not to rely on it. Yeah, it could be too. It could be it too, because there's more than one revision of the BIOS, isn't there? There's like what, three revisions of the BIOS that I'm aware of, anyway. BIOS calls. See also. Oh, GitHub. Two actual revisions and a logo edit for the twin Famicom. Ah, there it is. Okay. Someone explained the fact that the Game Boy loads and compares the Nintendo logo pixels to a copy in RAM by making a cart that returns the correct pixels in the first read, the address, and anything the ROM maker intends to have on the screen the next read back. Yeah. Yeah. I'm not as familiar with the Game Boy workarounds, but you know, yeah, it's similar to what I believe it's similar to what the disc system is doing with the copyright notice thing, but I mean that's easy enough to bypass as well. Yeah. Oh, I want. Why did I do that? E, capital E. Thank you. Post copy. An FPGA Game Boy cartridge. Oh, nice. Oh, that jumps to the reset back there. 9D. 9D and then jumps to the... Okay. 9D. 8, 9. What's D? 1101. Try to consult my D for the 50 spice if you want a better routine levels. Yeah. Where do you got that? Yeah, that's on. Is that on over here somewhere? Zoom out a little bit. Is it out? Is it in here? These guys? Yeah, I'll look. I will probably prepend FDS to these, but oh. FDS disk keys. Disk sys. This one. All right. Yeah. I'll have to fold that in, I guess. But anyway, I'm losing steam, so I think I might wrap up. Yeah. But we made progress tonight. We made a lot of progress tonight. Yeah. I think I did anyway. So really missing labels for the license screen check and the logo idle screen stuff. Yeah. Is that a like full disassembly with everything? Pull out notes and things. That's not what I want. Sure. Oh, okay, data ranges. All right. This guy all over this guy. Yeah. Okay, that's good. Most of it then. Right, yeah. Yeah, this is the same config stuff that I'm using here. Yeah, same exact stuff. Go ahead and... All right, I already had that start, okay. Oh, right, this is where I got that number of 3 different revisions. That's where I got this. Yeah. No. Anyway, I'm gonna wrap up because I'm getting a little hungry. I need to get some food. Yeah. But I think we made good progress tonight. I think I was able to figure out how to make a disk system ROM, whatever the hell, and some other weird shit with LD65 and getting things assembled the way I want them to be assembled. So that's nifty. Yeah. Anyway, let me find someone else that is live. We'll go raid them and say hi. I should be back this coming weekend, right? Maybe actually. I don't know if I'll be around on Friday. I don't know about Friday. Sunday I should be, but I don't know about Friday. That one's going to be up in the air. That's the day after Christmas. I don't know. Keep an eye on Discord for that one. We'll see if I'm up for it then or not. What's this guy doing? Turn off the audio for you. The Feast of Stephen? Who? Feast of Stephen. Maybe not over there. All right, let's see. So who's Stephen? What? I'll go with you guys named Steve. You can also just use your ROM card and just software switch to disk mode if that's what you need. Yeah. So I don't have any. The only ROM card I can use for that is the EverDrive, and I don't know if I want to use that on the thing. Honestly, even if I did use it, I'd want to use it through this monstrosity, which scratches out the IRQ pin, so the IRQ on the cartridge is ignored. It does some weird shit with it, where it'll like interrupt it. I found that out when working on some titler stuff, because the titler uses IRQs for the touchpad, right? And breaks things if there's some soft locks. I don't even know if it's really an actual soft lock. It's more like a hard lock, I guess. I'm uncultured. That's what it is. Got it. Got it. I understand now. I'm just uncultured. It doesn't touch the RQ line, but I don't know what the FDS does with it. Yeah, so there's some FDS stuff that screws with the IRQ, specifically around what's it? The DRAM refresh, I think. Spin weights on IRQs. Boxing Day. I see. What is this? What is this person doing? What is that? Oh, let's go over here. This is someone I do not know. Come with me to say hi, though. I'd really appreciate it. Like I said, I should be back at least part of next weekend. Friday is up in the air. I'm not sure if I will be live on Friday. I'll let you know on Discord either the day of or whatever. Yeah, we'll see. I should be back on Sunday regardless, though. Yeah. Thank you guys for being here. Come with me to say hi. Really appreciate it. You guys have a good night. Bye.